Welcome to my video on factoring perfect cube binomials. So first of all, let's establish what a perfect cube is. If you are talking about an x cubed, well, we know that x cubed means x times x times x. So definition of a perfect cube, something times itself, that gives you that number, or in this case, letter. Negative 64. Well, what can I multiply together 3 times to get negative 64? How about a negative 4, a negative 4, and another negative 4? So there's your definition of a perfect cube. So to factor these guys, it's kind of like a normal binomial factoring. So most factoring problems end up looking like this. You get a pair of binomials in there. So almost the case with this guy. So the only thing we're going to do differently is we're going to make that second set of parentheses a little bit larger. Here's why. So we're going to start off the same as you normally would with a normal factoring problem. I need something times something that's going to be x to the third power. So I always reference this as like this. There's a small set of parentheses and there's a big set of parentheses. The small set of parentheses gets the small amount. The big set of parentheses gets the bigger amount. So if I want an x cubed, I put one of the x's in the small parenthesis. I put the other two in the big parenthesis. So same thing with the number on the end. So normally we would say for a normal factoring problem, hey, I need something times something. It's going to give me a negative 64. Well, here we go. Small one in the small parentheses. Now I'm going to leave the signs off for a second here. Show you why in a minute. And I'm going to put the other two 4s in the other set of parentheses. Now, I'm not going to leave it 4 and 4. I'm going to multiply it back out. And I got a 16. So to double check, 4 times 16 is 64. Again, I know that's not negative 64, so bear with me for a minute. So the middle term is usually the one everybody forgets how to do. Like anything else, if you memorize something, you got it down, you don't forget it. Whatever you just wrote in the first set of parentheses, happy face, multiply those two guys together, write them here. If there's an x, there's a 4. X times 4 is 4x. And so here's my way of remembering what the signs are. So, I mean, yeah, you could have probably worked with the signs there to start with, but I just use this acronym right here. And oddly enough, years later, my students will say, hey, Mr. Paul, the only thing I remember from your class is what SOAP stood for. Here's what SOAP stands for. Same, as in use the same sign that was in the original problem. O stands for opposite. So whatever sign you just wrote, go opposite. Plus. And I always called these last two guys always positive. Then some of my students said, you're not being very nice. So how about add, please? Bingo, done. So perfect cube factoring ends up with a binomial and a trinomial. Let's try another one. So 8n cubed plus 27. So guaranteed, if you have a binomial with a perfect cube, it's a small set of parentheses and a big set of parentheses. So the question is, what times what is 8? Well, we can even skip the whole perfect cube part as far as listing them out and just say, hey, 2 times 4 is 8. Put the small one in the small parentheses, put the big one in the big parentheses. How do I get that n cubed that goes with them? I'm going to put the small amount in the small parentheses and the big amount in the big parentheses. That gives me 8n cubed. Let's look down here on the end. I got a 27. Yeah, what times what's 27? 3 times 9 is 27. I get the small number in the small parentheses. I get the big number in the big parentheses. Take these two guys, times them together, make a smiley face, and you got 6n. Sorry about my terrible n. SOAP stands for same, as in the same sign it was in the original problem. Go opposite of that and be nice and add, please. Done deal. Just a little extra tidbit here. A lot of times people see this guy on the end here and they see that n squared and they sort of assume it's going to factor again. Perfect cube factorings are one and done. Little parenthesis, big parenthesis, and that's all she wrote. Let's look at one more. Big number, who cares? What times what is 1,000? So if you need to break it down just to figure out perfect cube wise, hey, is it perfect cube? Is it not? Well, what's 10 times 10 times 10? Hey, that's 1,000. So it's a perfect cube. So small amount, small parentheses, big amount in the big parentheses. Here we go. Small set of parentheses, big set of parentheses, binomial, trinomial. 10, 100. I don't want to leave a 10 and a 10, simplest form for math. Just noticed this guy has a typo. So this guy's supposed to be a cube right there. Otherwise, he wouldn't be a perfect cube in the first place. Well, W cubed. If I put one W here, two W's there, then I get myself a W cubed. So small amount in the small parentheses, big amount in the big parentheses. So that guy's covered. Z to the third. One Z here. Two Z's there. That gives me a Z to the third. Done deal. Take these two guys, get happy, times them together. 10WZ. SOAP stands for same, as in the same sign that was in the original problem. O for opposite. Go opposite of that. Add please or always positive. And that is all she wrote. Hey, thanks for watching.